Welcome to the second assignment that we're looking at in Chapter 8. This is the 8-1.2 assignment. It's located in your assignment tab of your notebook. This particular assignment is focused on finding the product of powers, so we're going to talk about what that means. By the end of the lesson, we should be able to simplify expressions involving powers of monomials. So there's that word that we learned yesterday, monomials. So just a reminder to you, if you have a number, a variable, or a product of numbers and variables, that's going to be a monomial. So we're going to be looking at powers more specifically. So we'll just get started right away. An expression of the form x to the nth power, so that's how you say that, x to the nth power, it's called a power. So I'm going to zoom in here and let me get a pen. So P-O-W-E-R. So that is a power, and it represents the product you obtain when x is used as a factor. Factors are just numbers that are multiplied together, and you're multiplying them n times. So the number x is referred to as the base. It's all about that base. And the number n is the exponent. So here is an example in this box where you have your x is 2, your n is 5, and then this is kind of what that means for us. So just to kind of review what we just said, the 2 is the base, the 5 is the exponent, and then when you have something where it's 2 to the 5th, it means that you're going to have 5 factors of 2. So when I look at this, it really just means 2 times 2 times 2 times 2 times 2, and there are 5 2's there. So there are 5 factors. So I'm just going to write that above here, 5 factors of 2. If you were to figure out what 2 times 2 times 2 times 2 times 2 is, that is 32. Now, just so that you guys are aware in your calculator, if you wanted to find the answer to this, if you did 2, and then there's this arrow button, like the caret button above the division sign, that's going to be like, hey, I want an exponent. And then you would type in 5 because our exponent is 5, and then hit enter. And the answer is 32. So it says, in the following examples, the definition of a power is used to find the products of powers, meaning we're going to start multiplying monomials that have an exponent. So look for the pattern in the exponent. So on the left, we have our first example. So looking at this, we have 2 to the 3rd power times 2 to the 5th power. So 2 to the 3rd means that we have 3 factors of 2. So 2 times 2 times 2. 2 to the 5th power means that we have 5 factors of 2. Now, if you were to count up all of these 2's, we would have 8 total factors. So 3 factors plus the 5 factors are going to give us a total of 8 factors, which is 2 to the 8th power. So we started with 2 to the 3rd power times 2 to the 5th power. 3 factors in the first monomial, 5 factors in the second monomial, and then ended with a total of 8 factors. Taking a look at the next example, we have 3 squared, or 3 to the 2nd power, you could say that, times 3 to the 4th power. So 2 factors in the first group, and then 4 factors in the second monomial, for a total of 6 factors. So what I'm hoping that you are noticing as you look at these 2 examples, in order to come up with this 8 or this 6, the exponent at the end to simplify, all you're doing, if they have the same base, so in this case they both had 2's for the bases, all you're going to do is take your exponents and add them together. So we did the 3 plus the 5 is 8, and we kept the base the same. The 2 plus the 4 gave us the 6, and we keep the base the same. So productive powers, in words, to multiply two powers that have the same base, add the exponents. So for any number a and all integers m and n, this is what it's going to look like. So if you have a to the m power times a to the n power, so notice we have the same base of a and we've got the exponent m and the exponent n. All we need to do in order to simplify this is add our exponents together. So the base stays the same, we've got a, and then we take the exponent m and add it to the exponent n. So this is kind of just with variables showing what the relationship is when you are multiplying powers. I'm going to give you an example here that actually has numbers. So if we have a to the 4th power times a to the 12th power, what we're looking at is we keep the base the same, so the a stays, and then we want to take these exponents and add them together. So 4 plus 12 is going to equal the same base, and 4 plus 12 gives us 16. So this is something where we can't use our calculator to figure it out, so we have to remember this rule, that when you have bases that are the same, you are going to add your exponents. So now we're going to take a second to look at some example problems. So it says, example, product of powers, we're going to simplify each expression. And then it says, note, use the commutative and associative properties to adjust order and grouping. So commutative just means that we can change our order, and associative means that we can change our grouping. So what I'm going to do is I'm going to start by looking at this first problem here. So we've got 5x to the 7th times x to the 6th. So if you look, we have this x as a base and an x here as a base. So we'll end up having to add some exponents. But I want to change my order up a little bit so that you feel a little bit more comfortable. So whenever you have an x and there is no number out in front of it, it's like a phantom number that's there. It's going to be a 1. There's a 1x there. So what I'm going to do is I'm going to kind of change my order around so that I group my numbers first and then my my variables. So I'm putting 5 because that's the first number I see. So that's coming from here, and then I'm putting the 1 from the other grouping. So I've got 5 and 1. Then I've got my x to the 7th power that I'll write. And then from here I've got my x to the 6th power. Okay, so this is me just taking it and changing the order so that the numbers are together and then the x's are together. Because when I do that, I've changed the order, now I'm going to work on the grouping. So I'm actually going to do 5 times 1, and I'm going to do this x to the 7th times x to the 6th. Now when you multiply powers that have the same base, all you're doing is adding your exponents. So the base stays the same, and you add the exponent 7 plus 6. Now once you get here, you're just doing some simplifying of these numbers. So 5 times 1 is simply 5. And then this 7 plus 6 is going to give us 13. So we've got the base of x and then to the 13th power. And this is our answer in a simplified form. So again, just a reminder to you, we changed the order so that we could group the numbers together. So numbers together, x's together, then actually group them, and then simplified from there. Okay, taking a look at B, we want to do the same thing. So we're going to start by putting our numbers first. So we've got the 4, and we've got the -7 from the other monomial. So those are our numbers first. Next, I'm going to do my a and my a squared. So a times a squared. And then we've got b's, so b to the 6th and b to the 3rd. B to the 6th, b to the 3rd. Okay, so now we've kind of changed our order. So we've got the numbers together, we've got the a's together, we've got the b's together. Now we're going to actually group them. So 4 times -7 And then we've got, when we do a times a squared, anytime it's just a letter, like a number, a variable like this, and there's no exponent, it's assumed that it's a 1. So when you do this, you've got a to the first power and a to the second power, and we want to add those exponents together. So a stays the same, and we've got 1 plus 2. Then for the b's, we want to keep the base of b, and then we've got the exponent 6 and the exponent 3, so we're just going to add those together. So 6 plus 3. Once we've gotten to this point, we can do a little bit of simplifying. So 4 times a negative 7, a positive times a negative number is going to give you a negative. 4 times 7 is 28. And then we want to keep our bases. So I've got a base of a, and 1 plus 2 is 3. And then we've got a base of b, and we've got 6 plus 3. So 6 plus 3 is 9. So our answer in simplified form is negative 28, a to the third, b to the 9th. Okay, so again, change your order so that you've got your numbers together, all of your variables that are similar, the same, together, and then you can group and simplify. Part C is a little bit easier just because there are no numbers involved. You could pull out ones to the front, but it's not going to change anything, so we can just focus on what this means for our variable. So we've got the phantom 1 on this x. So all of our bases are the same on this. And we've got 1 plus 4 plus 6. So when you look at that, we're getting that from these exponents. We keep the base the same and then add all of the exponents together. And when we do that, we're going to keep the base, and 1 plus 4 is 5, and 5 plus 6 is 11. So that one was a little bit simpler just because there was no number involved. Last example here, we're going to look at this. We've got 4a to the fourth b times 9a to the second b to the third. So we want to start by reordering. So I've got 4, a 9. I've got my a to the fourth power from the first monomial. I've got my a to the second in my second monomial. And then I've got a b and a b to the third from the second one. So again, all I'm doing, like if you're struggling to see this, I put my numbers first, then I did my A's next with their exponents, and then I did the B's together. So a B and a B to the third. So I just kind of organized them so that I've got the numbers, the A's and the B's, so that they're side by side. From here, we can combine. We've got 4 times 9. That's going together. We want to do a to the fourth times a to the second. For that, we have to add the exponents, so 4 plus 2. And then same thing with these. It's a phantom 1 on the b, so we want to do keep the base, so we'll have a b. And then we're looking at 1 plus 3. We are adding those exponents, 1 plus 3. So anytime you multiply powers, you add the exponents. And from here, we'll simplify. 4 times 9 is going to give us 36. And then a to the, we'll keep the base a, 4 plus 2 is 6. And we'll keep the base of b, 1 plus 3 is 4. So I hope that this kind of makes sense, where you are reorganizing so that the numbers are together, all of the A's are together, all of the B's together, or whatever kind of variable you have, but keep the like variables together. And then you're grouping so that you can simplify. If you have questions, don't hesitate to ask. Your job is to now do these problems here in the assignment section. So there are 2, 4, 6, 8, 10, 12. There are 12 questions, and I am going to post another video where I do a couple of these, so you're welcome to watch that.